Hi, welcome back to my YouTube channel. I am Likita from CSE branch. I am pursuing my education in Sri Venkateswara College of Engineering. Today's topic is F distribution. Subject code is BCS 301. Subject is Mathematics for Computer Science. About F distribution. What is it? The F distribution is continuous probability distribution that results for comparing the variance of two samples or populations. It's also known as Snedekos F distributions or Fisher-Snedecor distribution. How it's used? The F distribution is often used in hypothesis testing and analysis of variance. How it's identified? The F distribution is uniquely identified by its two degrees of freedom, one of the numerator and the one for the denominator. The number of degrees of freedom controls the shape of the F distribution. How to find F value? F value can be found using F table, or you can follow four steps. That is, step 1, find the column that corresponds to numerator degree of freedom. Step 2, find the three rows that correspond to denominator degrees of freedom. Step 3, find the row that corresponds to probability of interest. Step 4, the F value is where the column and probability row intersect. Assumptions. For the results of F-test to be valid, certain assumptions must be met, including independence of observation, normality of data, and homogeneity of variance. Understanding the F distribution. F distribution is also known as Snedeker's F distribution or Fisher-Snedeker's distribution. It is continuous probability distribution that arises frequently in statistics, particularly in the context of variance analysis and hypothesis testing. It is named after Reynold Fisher and George W. Snedeker, who contributed significantly to the development and application of this distribution in the field of statistics. Characteristics of F distribution. The F distribution is used primarily to compare two variances, and it is mostly commonly associated with the analysis of variance, that is ANOVA, and F-test. The shape of distribution is positively skewed and depends on two parameters: degree of freedoms for numerator D1 and degrees of freedom for denominator D2. These parameters are related to the sample size or the number of groups being compared in the analysis. The probability density function PDF of F distribution is more complex than that of other distributions such as normal or T distribution, and it is not symmetrical. The distribution is bounded on the left by 0 and has no upper limit, extending indefinitely to the right, which reflects the fact that variance are always non-negative. Calculating probabilities with F distribution. Calculating probabilities from the F distribution typically involves using statistical tables or software, as the integral of PDF does not have closed form solution. The cumulative distribution function CDF is used to determine the probability that an observed F statistics will fall within a particular range. For example, in an ANOVA test, one might calculate the probability P of value associated with the observed F statistics to determine the likelihood of observing such a value if the null hypothesis were true. A small p-value indicates that observed difference among simple means are unlikely to have occurred by chance, leading to the rejection of null hypothesis. Assumptions and limitations. When using the F distribution in hypothesis testing, certain assumptions must be met for the result to be valid. These include independence of observation, normality of data, and homogeneity of variance across the groups being compared. Violations of these assumptions can lead to incorrect conclusion. For instance, if the assumption of homogeneity of variance is not met, the F-test may be too liberal or too conservative, leading to an increased risk of type 1 and type 2 errors. Applications of F-distribution. The F-distribution is primarily used in the context of hypothesis testing when comparing sample variance. One of the most common application of F-test in ANOVA, where the ratio of two mean squares is used to determine whether the observed difference between the sample means are statistically significant. In F-test, calculated F-statistic follows the F-distribution under the null hypothesis, which typically states that there is no difference between the population variance or means. By comparing the calculated F statistics to the critical value from the F distribution, one can decide whether to reject the null hypothesis. The F distribution is also used in regression analysis, particularly in the test for the overall significance of regression model. This involves comparing the model's explained variance to the unexplained variance, leading an F statistics that can be assessed against the F distribution. Conclusion. The F distribution is a fundamental tool in field of statistics, particularly for comparing variance and testing hypotheses about population means. Understanding its properties, applications, and assumptions underlying its use is essential for conducting accurate and reliable statistical analysis in various research fields. While the F distribution may appear complex due to its reliance on two parameters and its skewed shape, modern statistical software has made it accessible for statisticians and researchers to apply the F-test in their work without delving into intricate mathematical details for distribution itself. I hope you could understand something about F distribution in mathematics. Thank you.